Okay, Aubrey, and are we recording for anybody else? I don't think so. Just Aubrey? Oh, Wyatt, yes. 3-4, writing proofs. We are in the second half of 3-4. Here we go. Bottom of page 181 on the side. We have different types of proofs. Write this down. Proofs. There are different kinds of proofs. There is one that is my favorite. But some of the other ones are not very nice, okay? There is something called a flow proof. Okay, a flow proof has like little boxes, and this is what a flow proof, it looks like a flow chart kind of. Okay, so you have like a piece of information, and then they will draw arrows. It's like a visual description of like how things work, and then they might have like a box that goes this direction, and it leads to a conclusion, something like this. This is what a flow proof looks like, not my favorite. Okay, they have a paragraph proof. I want to guess whether that's my favorite. Paragraph proof is exactly what it is. It is explaining your reasoning in a paragraph. Not my favorite. Okay. The main one that we will use is something called a 2-column proof. Okay. 2-column proof. This one is my favorite. In fact, on the homework assignment, if they ever ask you to write a paragraph proof or write a flow proof, we are not going to do that. We are only going to write 2-column proofs because they're the easiest to get your thoughts onto paper. It's like the most straightforward way of doing it, okay? So a 2-column proof, you have 2 columns, and on the left column is something called statements, okay? And the other one is reasons, okay? So I'll just give you a proof really quick. Oh, do I want to do that? Yeah, I do. We're going to do our first proof real quick. I'm going to make this up. Put this down in the corner. Let's say we have to start with something that you are given and something that we are trying to prove, okay? They will give you this every single time. They'll give you this information over here. Colton, are you watching this? Okay, but you need to look also. I'll move back. Okay? Given proof. Let's say I have, 2x minus 7 equals 9, and I'm trying to prove that x equals 8, okay? This is something called an algebra proof, okay? Algebra proofs are very easy. You will like these. Algebra proofs are very easy. You will like these. All right, so we have to start somewhere and we have to end somewhere. Here we go. We start with 2x minus 7 equals 9. We start with the given. We start with what we're given. We have to start somewhere. We have to start with what we're given. Okay, that is my first statement. And for reasons, are you watching this? For reasons, I put the words given. That's what I'm given, right? The first step should always be your given step. I have to start somewhere. I get to have that as like my freebie. You have given as your first step, okay? Now I start to do the algebra. So if you were to do this, you would do what first? Add the 7 over, right? So my next line would say 2x equals 16, okay? Now, how am I able to do that? What's my reasoning for that? This is the addition property of equality, or just the addition property, right? Okay, the addition property says as long as I do it to both sides, I am okay. I added 7 to this side to make it go away, and I added 7 to this side. So by the addition property of equality, my equal sign remains the same, right? It stays in balance as long as I did it to both sides. So I have that going on. All right, now, my next line is x equals 8. How am I allowed to do that? The division property of equality. I'm going to go POE, as that's how we will abbreviate it. The division property of equality. And guess what? I am done with my proof. I have gotten to the point where I know that x equals 8. Here is the justification for why that is true. And I am done. Okay?
So pointless.
This was like a really short one. It gets to be longer than this, okay? So I'm just showing you an easier one just to get your feet wet, but this was our first proof. It will get longer than that. Okay? What? I'm sorry. But you guys have been in a situation before where you have to do some pretty thick problem solving, right? Like where you're like, okay, this comes out to be this, but then if this is true, then that has to be true, right? and then you're trying to come up with, and you're trying to figure out what that means, right? You guys have done that before. You've sat down and tried to do some problem solving, right? This is just showing that problem solving with a 2-column style, right? This is 2-column proof, okay? Got it? And this was an algebra proof. Those are much easier than like geometry proofs. So let's talk a geometry proof right here. Here we go. Okay, let's do this. All right, here is a geometry proof. You will not like this as much, okay? But they do make it a little bit nicer for us in the fact that they give us blanks. So like we know what it is kind of that we're looking for, that type of thing, okay? So here we go. Are you ready? There's going to be some weird things that you're going to be like, what the heck? Why is that true? Like, I don't like that, okay? That's just going to be part of it. Sorry, okay? Here we go. Ready? This is saying that what we're given is that Q is the midpoint of PR, right? This guy is the midpoint, right? Agreed? That's what it's given to me, right? That's my first step of my proof is that Q is the midpoint and it's given. That's what they write down first. We have to start somewhere, all right? Now, what they're saying is we are trying to prove this. What does that say?
PQ is equal to...
What is this symbol? Congruent. Congruent means what? The same shape, same size, right? Okay. PQ is congruent to QR, which means this guy is the same in length as that guy. Is that true if that's the midpoint?
Yes.
Like if this whole thing was like let's say 14, what would each one be if that's the midpoint? 7 and 7, right? Like that just has to be true, right? Okay. So here is something. Okay, you two boys, you have to listen to this. Proofs are hard. Come on. If Q is the midpoint, then PQ has to be equal to what QR is, right? Those two things have to be equal to each other in length, right? Okay? Yeah, true? PQ is equal to QR, okay? Why do I know that? Like, what tells me that PQ and QR are the same?
The midpoint.
Because Q is the midpoint. So this is like definition of midpoint, or you could also say the midpoint theorem. And we'll get to that. Midpoint theorem, I abbreviate theorem as THM. We'll talk about theorems later, okay? But midpoint theorem, because it's the midpoint, duh, these two sides are the same. That's what tells me that those two sides are the same, okay? Now, if two things are equal, if two segments are equal, does that mean they're congruent? Congruent means same shape, same size, right? But like lines don't really have a size. So if they're equal in measure, then they're the same shape, same size, right? Like they're congruent, okay? And that is definition of congruent. By definition of congruent, if two segments are the same length, they're going to be congruent, okay? So remember that definition of congruent is just taking it from equal to congruent, that type of thing. That's kind of a weird step, but that's like a proof right there, right? Okay, now again, that seems really silly because it's only 3 steps. We're just getting our feet wet. We will get to the point where we have like 5, 6, 7 step proofs. Those will be a little bit more unpleasant, but we're not going to start you with that, right? Yes, sir.
Will all the reasons be the definition of lot?
A lot of them will be, yes. Or like what you had yesterday where it was like postulate 3.7 tells me that that's why it is the way that it is, right? Or postulate 3.1, okay? Good?
Flow proofs.
We're not going to do any flow proofs. We will do them all 2-column style. Yeah. Okay, so we're going to eventually write these down on a theorem sheet. I will give you one of those. It's going to be like a different color sheet of paper that you're going to hold on to. But here's what the midpoint theorem says. It says that if this guy is the midpoint, then that means that this thing is congruent to this thing. We just proved that, right? That makes sense. That side is the same as that side. Those two things are congruent if that's the midpoint. That is something called the midpoint theorem. All right? Okay, let's go down and let's do something. This is a little bit harder. So this is why proofs exist. For this very reason, this is a little bit harder. Are you ready? Buckle in. Understanding the given is like probably the hardest part. So it says B is the midpoint of AC. Okay. This guy is the midpoint from here to here. Okay? Now we can go one step further and say, okay, that means that this is the same as that, right? So we can write that down, okay? All right, so that's one thing. B is the midpoint of AC. Cool. C is the midpoint of DE. Okay, this guy is the midpoint from here to here, which means that this guy is the same as that one. Now, why do I use two tick marks?
You don't know this.
Right, we don't know that these two lengths are the same as those two lengths, but we're gonna here in a second. Ready? Then it says, wait a second, AB, this guy, is the same length as CE. So now I know that this is the same as that one, right? Okay.
That means
they're all the
that
same.
We are trying to prove that BC is the same as DC. Would that be true?
yes.
Okay, these two are the same as each other, these two are the same as each other, these two are the same, but then those two are the same, right? Okay? That logically that makes sense, okay? Now, doing a proof is kind of like explaining to a fourth grader why that's true. And they're like, that doesn't make sense. Why does that make, and you're like, why can't you just see it? Why can't you just understand that, right? But you have to write out step by step. Okay, this is why, and you're just going through step by step why this is true, right? We know that that should make sense, but we have to write it out step by step so that we know that everything that we're doing logically is legal, right? Okay, so definition of midpoint. Here we go. Because B is the midpoint of AC, by the definition of midpoint, we've already marked it on our thing. We just have to write it down. Because this guy is the midpoint, I know that AB and BC are congruent. So I'm going to write that down here. AB is congruent to BC. Got it? Okay, if C is the midpoint from D to E, what else is true on that same line? If this guy is the midpoint here, DC is congruent to CE. By definition of midpoint, I know that that is true. Got it? Okay. Now, sometimes you will not list all of your given information at one shot. Okay? Notice here I wrote this piece of given information down, but then from there I basically milked information out of it, right? If these two things are true, then I pulled this information out of that, right? This means this is true, okay? Now I'm going to start with more given information. I'm not going to list it all at once. This is given to me also. A, B, and C, E are the same, right? I know that that is true, okay? So if that is true, then here's what I can do. I can, let's see. What do I want to do?
B, C, and C are the same.
Let's do this, okay? If I know that AB and BC are the same, can I take BC and plop it in that spot and say that BC is now equal to CE? You see how I went from this step to this step? I took BC and I plopped it in right there. Okay, so now BC is equal to CE. Okay? What did I do by plopping that into that spot? What's that called? I substituted that value in. Substitution, okay? Now, how do I go from this step to this step? Look at the difference. CE is becoming DC, right? But CE is equal to DC. So can I take can I take DC and plop it in that spot? Yeah, that's substitution again, right? So we're just plugging stuff in that is equal and coming out with the end result, which is here, which is I did that by substitution. Do you see how this works? Yeah? Ish, kind of? Good? All right, so we're just justifying why things are. I understand that when you go through this, you're like, well, duh, that just makes sense, right? But imagine that you're trying to explain it to a fourth grader. We're like, does that really make sense? Yes, logically, if we go through and we do everything legally and justify our steps, that has to be true, right? Okay, that's how this works. All right, let's do, I don't want to do this in a flow proof style.
I think we get it pretty well.
Let's do this 2-column style. Let's do it over here, okay? 2-column style. I'm going to do this same project, example 4. Do I want to do the example 4?
Macy, it's Wednesday.
I know. Should have updated it. What?
Let's,
Wednesday mean?
I don't know, which one do you want to do? Do you want to do example 4 or the check? Look at that page. Example 4 or the check? Do you want to do, which one do you want to do? No. Let's do the check.
Oh,
Okay, let's do the check.
Our table.
All right, here we go. Let's do this one. All right, 2-column proof style. We're not going to do flow proof. What's the left column called? Statements. Statements. Put this on your paper, and we're almost done. Statements. Go over here. What goes on the right side? Reasons. Okay, every single time you will label it like that. Statements and reasons. Okay. All right, let's look at what we have. They are giving to us that FG is this guy. He is the same as this one over here, HK. Those two are the same length, all right? And then they say prove that that means that X equals 7. Okay, we got to bridge the gap between those two. Okay, so we have to start somewhere. What's my first statement going to be?
4x plus 6.
No, not yet. Not yet. We start with the given. FG is equal to HK. That's given to me, right? Okay. FG equals HK. All right. Now what? 4x minus 6 equals 22. Okay, how do I go from this step to that step?
Fill them out.
So what I did was I plugged 4x minus 6 in for FG, because that's what it is, right? And I plugged 22 in for HK, right? So that's substitution. I just plugged those values in because that's what they are. Substitution. I can't spell. Whatever. Substitution. Okay? All right, now let's do some math. So now we are here. I'm getting away from the answer. Shh. What are you going to do first?
4x.
Okay, I'm going to add this 6 over. So 4x equals 28. And what's that called?
Definition of addition.
That's the addition property of equality.
No.
Do they call it something different?
No.
Okay, the addition property of equality, that goes down here. Whatever. Okay? All right, good? Okay, hold on. Back up. Back up. Let's do this. I'm just going to show you sometimes they do weird things, okay? Here we go. Back up on this step. Let's do this. 4x minus 6 equals 22. They sometimes do this weird thing, okay? Where they do an intermediate step because they don't believe you or something. I don't know why they make you do this intermediate step. So I'm going to do this intermediate step because sometimes they do this, okay? They do this instead. You're going to add 6 to both sides, right? Okay? So sometimes they'll write it like that and they'll call that step the addition property of equality. Your next step then is 4x equals 28. They call that, I don't know why, don't shoot the messenger, they call that substitution. Because substitution is like simplifying. So I'm simplifying and I'm substituting 0. I'm substituting 0 in place of this and I'm substituting 28 in place of this, okay? So just so you know, on your homework assignment, they might do some weird stuff like that where they do substitution, okay? Now, my next step, what are you going to do to the next thing? I'm going to divide by 4. So they will probably have you write it like this. I'm going to divide by 4 equals 28 divided by 4. And that is the division property of equality, okay? But then my final step will be x equals 7, and that is called substitution, okay? It's because you are substituting 7 in for the value of 28 over 4, and you're substituting x in for 4x over 4. So sometimes they will make you do it the longhand way, right? And like do the steps and the substitution. So I'm just saying, I'm just preparing you for when you have like, I don't know, like your proofs like this, right? And you're like, what the heck? I have way too many blanks and all of the things. It's because they added some substitution in there, like your simplifying step, okay? So just so you know, there is that, okay? Weird things, okay?
We ever have to prove that the we have to ever prove it wrong or something?
No. We will do something called proof by contradiction. Yes, we will do a proof by contradiction. But we'll get to that. We're just kind of like proving it wrong. Okay. The homework is number
14.
We already did 6, 8, 10. So do 14. Wait a second. Is that a nice one? Yeah, 14's an okay one. Okay, so do 14. It's going to be very similar to the one that we just did. Do that one for homework and then you're done.
I don't understand
Yay.
the last one. It does. It's literally nothing.
Yeah,
It's substitution.
it's substitution.
Wait,
Were you listening when I just went through?
Yeah,
No, he was not.
and what's number 4?
Substitution.
They're both
Proper
substitutions.
note.
There's a lot of substitutions in there.
Wait a minute, I thought we were on page 185.
We are.
Okay.
He's being a dum-dum.
Right.
Whatever. All right, goodbye.
Which question?